Hello, Assalamualaikum warahmatullahi wabarakatuh. Introduce myself, my name is Gustin Wardani, NPM 2013022030, study program Physical Education, Class B. 1. Work by a constant force. Suppose an object and apply a constant force in the horizontal direction. Concept of work. Suppose the force starts at point xi and goes to position xf and cause it the direction I. Formula can be written. Force dash object, displacement of dash object. So the vector of displacement is delta x equal to xf minus xi. Force for the case where fx is constant. The definition of work done by the force in moving the object from the initial position to the final position is the product of the force fx times the displacement equal fx times xf minus xi. This is the definition for case where force is constant. If the force fx is less than 0 and shift in the positive direction, then the work is negative. If the force fx is positive and the displacement is positive, then the work is positive. Work is the product of force and distance. As a unit, the unit of force, which is Newton, times meter equal joule. In the first graph, the x component of the force has some origin, has x, starting from xi and xf, and during this process, it assumes that the force is constant, so make a shadow in the area. That our work is the product of force and displacement. This is a working example for constant force. 2. Work by a non-constant force. The case playing force F is a function of x, so the component of fx is a function of x toward a head. The simple example of the force is called the spring force. Now we apply this style to the object. This is our positive x coordinate system. We apply force is a function of position. So look at the displacement in a smaller amount. So let's call this the point xj, and this is xj plus 1. How much work drop when the force is from here to here, and that's what's called delta x. So our displacement is delta x equal to xj plus 1 minus xj. Therefore, this displacement, why do we show with delta y equal to force f, a function of x time displacement? So you get fx xj plus 1 minus xj. If we want total work, we have to add j equal 1 to n fx of j delta xj. What does the number mean? That is what defines as work for in constant style. The problem here is about how will we cut this interval. So what is the limit size and becomes infinite, it needs to be considered. What we're doing is making the displacement smaller and smaller, and take this sum j is equal to I to n fx of j times delta xj. And its summation limit is by definite the force integral with respect to the x prime. So work is an integral of fx. A function has an integral variable x prime of the x prime, where x prime moves from the start to the end position from this figure. It is now a working definition that generates a constant to an inconstant force. Plotting fx versus x, pulling the force as if they were increasing as a function of x. Here fxf. We are going to make a geometry interpretation considering xj to be really big, xj plus 1, and the following here is fx of j. So what we see now is that as little effort as for constant force can be approximate to the area under the curve only for the small interval between xj and x1 xi plus 1. Now you see graphically that there is a slight error when the function is almost constant. But where does the function develop? That's our fault. But within limits because and become infinite, so that the error becomes smaller. On one more area under the force versus position curve between initial and final. That's our generation of the definition of work. 3. Kinetic energy. The kinetic energy K is equal to half mv squared. This is a scalar quantity, so be zero or positive. The SI unit for kinetic energy is the joule, derived from the kilogram meter per second squared. Suppose we have an object that is first at rest and then accelerates at a certain speed. It means that the object is expressing a change in kinetic energy. The change in kinetic energy is equal to half mvf squared minus half mvi squared. If there is movement, the speed inside 2D or 3D space, that half m then vxf squared plus vyf squared plus vjf squared minus our initial values xi, yi, and zi. How to install momentum and kinetic energy? So K is equal to half mv squared. Remember, P is equal to mv, so equal P squared is more than 2m. That is the kinetic energy expressed in the terms of the particle's moment. 4. Road kinetic energy theorem. Let's derive the work energy principle. Use Newton's second law, but not with time but with space. So F is equal to ma, taking the x component from it. Now we're going to integrate this, so fx dx prime goes from x prime to xf and x prime to xi. And integral routes the initial value to the sum ending value and has a x dx prime. The integral, so half vf squared minus vi squared. The value entered here get half mvf squared minus vi squared. This is change in kinetic energy. Integral fx dx we call v. And the work on that system is the change in kinetic energy. So this is the principle of work energy. Wassalamualaikum warahmatullahi wabarakatuh.